Okay, welcome back. This is part three. Part three is relatively simple and short. I just didn't want to tack it onto the end of that other one. I wanted you to kind of go through and get some time. So here's the deal. There is a formula for a general curve C. And if C is a smooth curve given by R of t, then the curvature is given by the magnitude of t prime divided by the magnitude of r prime. And if you think about it, if it is, this still works for if it's given in terms of the arc length parameter, because if you are given a function in terms of the arc length parameter, the magnitude of r prime is 1. So yes, this is a general formula that works. Why would you want to do all the reparameterization stuff? Sometimes you need to. Sometimes you do. Sometimes you don't. And so we're going to do this problem. Now, same problem, same function, r prime, we found it earlier, and we found the magnitude of r prime. If you want to know how to do that, go back to the other problem. We did it already. I'm not going to do it again, because no matter how long it's been for you, it's been about a minute for me. It's still pretty fresh. All right, so here's where things get a little different. Need to find t of t. Because remember, we're headed to find t prime. We already know what our magnitude of r prime is. All right, so t of t is defined as r prime of t divided by the magnitude of r prime of t. That's the definition. And so this is going to be 1 over the square root of 5, because r prime, magnitude of r prime is square root of 5, times this, negative 2 sine t, 2 cosine t, 1. Which is going to mean it's equal to negative 2 over the square root of 5 sine of t, 2 over the square root of 5 cosine of t, 1 over the square root of 5. All right, that's t of t. Now, I need to find t prime. Well, t prime of t is just the derivative of this. Well, that is going to be negative 2 over 5, 2 over square root of 5, sorry, cosine t, negative 2 over the square root of 5 sine t, 0. Took the derivative of each of these. See where this is going. We've done almost these exact calculations a minute before, but we didn't find them. I mean, we didn't put them, never mind. We didn't do them in exactly this order is what I was attempting to say. I don't know why it came out so badly. So this is where I'm at. What's the next thing I need to do? Well, the next thing I need to do is I need to find the magnitude of t prime. All right. Magnitude of t prime of t is going to be the square root of negative 2 over the square root of 5 cosine of t squared plus negative 2 over 5 sine of t squared. Both of these are square roots, sorry. Plus 0 squared. If you really want to see it, I'll write it. Now at this point, you've seen this algebra several times. This is going to be, let's see, 4 over 5 times cosine squared t plus sine squared t. All right. So this is going to be the square root of 4 over 5, which is 2 over the square root of 5. And at this point, you might be saying, but Jamie, that's different than what we got a while ago, which would be really odd because you shouldn't be calling me by my first name. But if you had said that, you would be right, and the reason is because we're not quite through. Remember, when we don't have the arc length parameter, it's not just the magnitude of t prime, it's the magnitude of t prime divided by the magnitude of r prime. So k is going to be 2 over the square root of 5 divided by the square root of 5, which is 2 over the square root of 5 times 1 over the square root of 5, which is 2/5, which is the exact same answer. Now, I'll tell you, a lot of people like this because if you'll look at this, all the way through, we never had to deal with the chain rule thing on our t, and that's nice. And especially if, this magnitude of r prime is very nice to deal with, this method works great. But it all comes through that arc length parameter, and it's only because the arc length parameter does not vary with, because arc length doesn't vary with parameterization, that we can do this and still get the same answer. So yeah, the arc length part is important, and you need to learn about reparameterizing to arc length parameter because there are times that's nice, but if you're just looking for curvature, this will usually work for you. On a test, you can use whichever method you want. You can reparameterize or not. I'm not going to specify. So that's up to you. All right. So that finishes up 12.5. That finishes up vector valued functions. And man, I really wish y'all were going to be in class with me so I could do the sequence and series stuff. But we'll deal with it as it is. Have a good one.